Hello. So we are here ready to get to meet you all. Not all the confirmed applicants are here, but since you're already here, let's not wait. And I'm sure they can join because we sent out the links. That's how you came here. So okay, you can all hear me, right? Any problems in the connection? Okay. So let me share my screen. So we're going to get to know you guys too in a minute, but let's just introduce the workshop and the team, and then we'll hopefully get to know you guys individually. So for the ones who have not seen our introduction previously to the local intelligence workshop and our research, we are experimenting on the local intelligence means, and it's on open source algorithms and CNN and GANs and understanding the localness or locality. We're going to be using these two terms for the same thing, actually, and vernacular architecture with local folklore music. And we call it music to architecture, architecture to music, as in Pix to Pix, right? So we're going to be working on local data sets, and we have already invited our participants to go ahead and prepare their own data sets. But we have the data set that we're going to be using during the workshop. Apart from that, if you want to contribute to the research and use it during our workshop, we're happy to guide that too. So who we are, I am Lale Başarır. I have a PhD from Izmir Institute of Technology. My research is on artificial intelligence architect ArchiRobie. It's continuing in Izmir University of Economics. And I am an assistant professor in Department of Architecture. So I can call myself interdisciplinary, just because to explore and uncover diverse knowledge, I believe that all of us need to stay interdisciplinary. So I graduated from Gazi University in architecture, and then a second degree at CCAC in San Francisco. I studied industrial design, and then in ITU, Istanbul Technical University, I got my master's degree in architectural design computing program, which is our main common side with Selen Hoca and Mustafa Hoca. And then I finished my PhD at Izmir Institute of Technology. And I have been teaching since 2011, architectural design studio, basic design studio, BIM and CAD drawing and artificial intelligence in architecture courses in Yaşar University and Izmir University of Economics. So now let's pass to Selen Hoca, Selen Çiçek.
Hi everyone, as Lazlo just mentioned, I'm Selen, and I'm also coming from an architectural background. So I have graduated from Middle East Technical University's Architecture Department in 2020, and I directly started my master's studies in Istanbul Technical University's Architectural Design Computing program. So I worked with Lazlo at Izmir University of Economics as a research assistant. We're both guiding through various aims in architectural design computing, such as machine learning, computational basic design education, and also my research interest includes space syntax applications and so on and so forth. So I will be glad to look with all the examples of the machine learning algorithms in terms of them, data preparation methods in the upcoming slides and the workshop days. So I'm happy to meet with you, and I'm looking for the results. I'm excited for it. So see you.
And Mustafa Koç.
Hello everyone, welcome again. And I'm Mustafa Koç. I came from a little bit different background. I'm an electrical and electronic engineering. I completed my master's in TOB University in both electrical and electronics engineering and architecture. And then now I'm doing my PhD in Istanbul Technical University. I will be very pleased and happy to help you and work with you.
Thank you, Selen and Mustafa. So we're going to be working on this multimodal model, and we're going to introduce the algorithms, and we will be working on music data and architectural image data. And yeah, just as an introduction, we have prepared our data sets on music, and we're going to be converting that music data to image data, and then use Pix2Pix to produce the GAN model, and use finally get the output of local intelligence from those both inputs as the music and architectural image data sets. So these are the spectrograms, and you're going to be introduced to all this information throughout the workshop. The learning objectives, you will have access to the knowledge on how to train machines with audio and image data on Google Colab. Our working platform will be Google Colab. Gain hands-on experience in building up a model that will bring together different AI models, and be introduced to the theoretical background of the CNN and GAN machine learning models. So programs and knowledge required to carry out the workshop. I'm sure you have access to this information from earlier, the Digital Futures platform. All skill levels, and we're going to find out in a bit about the knowledge and skill level of each of you. And since Google Colab will be used for training, the model internet access would be enough. And participants are free to use other IDEs if you have already set up the environment for coding purposes in Python. Expected results of the workshop. The output will be visualized as a map of local possibilities. Students are expected to have new insights into how two different creative activities, as music and architecture, can interact in the data scapes. And our schedule, we already started, and we're going to be talking about local intelligence and then theoretical background, introduction to machine learning, and data set collection and preparation. That will be enough for today. And tomorrow, again, data set collection and preparation and task-related problems and solutions. We're going to look into any problems that we might face throughout the process. And then data set collection preparation, reviewing the collected data sets and discussion. And then training of the machine learning algorithms on Google Colab, CNNs and Pix2Pix and CGANs. And on the final day, we're going to still be working on the training of the machine learning algorithms, and we might have some surprising additions to what we're going to be doing with the same data and same models, but changing the place of the input and output, and reviewing the outputs of training of the workshop participants. That will come from you. And the discussion, finally, the future projections for the application of local intelligence. So now let's hear from you. Why were you interested in the workshop and what are your expectations? And let me stop sharing right now.
If it is possible, you can open your cameras to see your faces and meet you in person, some kind of like that.
So, Jing Chan, just a second. Could you repeat how you pronounce your name?
You're muted, by the way. Your microphone is closed.
Let me see. Okay, that's okay. So I'm Tao. You just call me Tao. Maybe. Yeah, just from China and the Chongqing University. What I focused on the AI is something about I want to find something like interpretations between humans and machines. Maybe artificial intelligence can give us some inspiration from the calculations and the regenerations from the genes of the facades, from the genes of the style, because I saw some samples from EPFL, the school of the EPFL, they found some genes of the Switzerland. So from that time, I focus on the machine learning. So I found that this local intelligence workshop has a special factor about music. So it's make my interest about the music, how AI learning. because I saw some pixels to pixels like or style games, but I never touch about the music. So that's my my attention to this workshop now. Thank you.
Thank you for joining us.
Thank you.
So we have Yerwant. Is that how you pronounce your name?
Yes, Yervant, yes. Yeah, I just logged in with my phone also actually, so you could see me in the other screen. You can see my face. So yeah, I'm doing a master's in Barcelona right now in IARC, and I just finished my first year. And it was like heavy computation, and next year is gonna be my master thesis. So I'm also a musician, so this was pretty interesting to me because I wanted to try to see if I can somehow integrate AI into the concept phase of my project as a collaborator for generating ideas. And especially when I saw this, that it was related to folklore music and vernacular architecture also. So I was pretty interested to see, yeah, like what's the relation and what can this generate geometry or space-wise or image-wise even, and see if it's something that I would want to explore more. But just a disclaimer, yesterday was the first Python tutorial that I did on Grasshopper. So like I have an idea now how it works, but I'm not even a beginner. So yeah.
Well, that's fine, since I mean some basic knowledge can be helpful, but you're not required to code, and you're gonna see how we're gonna be guiding you guys throughout the workshop. And thanks for joining.
Thank you.
And who else do we have? Kaan, Çetin? So I just called out two of you who already started their videos. Otherwise, I may imagine that you don't want to interact right now. Maybe it's too late or too early at your time range. And okay, I'm seeing Kaan. Would you like to introduce yourself?
Sure. Is everything all right about my voice?
Yes, we can hear and see you.
So hello, I'm Kaan, and I just finished my architecture degree the 2020, and I'm just interested in the AI text-to-image generations. And my previous renders and previous works, I just using the input to basically to doing that the first time. I use the Disco Diffusion and some kind of different open source machine learning softwares on that part. And this workshop interests me about of course, the musical inputs. I just heard about the first time. And is interested from me, and I want to participate and to produce the images and the works with the this audio thing. And yeah, that's all.
Okay, so thanks for joining us, and I'm sure we're going to get to know each other in these 3 days a lot. And if there aren't any others who would like to introduce themselves, we can go on with the introduction lecture part. Okay. Sharing my screen. So as I said earlier, can you all see the screen? I think you can see the screen, right? Right? Selam hocam.
Yeah.
Yes.
Tabii görüyoruz.
Aşağıdaki tabii, evet, onu şey yapamıyorum. Neden acaba? Okay. So as I said earlier, this is an experimentation, and what we believe is we have been training AI so far, but now it's time to learn from AI, right? We can definitely get a lot of insights from AI since it has huge power of processing data and information, right? So this will be an experimentation, and you will be, as I said earlier, setting up a multimodal AI model and try out other data types. We'll be using open source algorithms, CNN and GANs, and the data sets that are required for the model to process and output what we are expecting. And we are also open to things that we're not expecting. And we're open to the outputs that the computer will give us from the latent space, right? So we want to understand localness, and for that, the methodology is correlating vernacular architecture with folklore music. So what we're after is the tacit knowledge of architecture and what it holds for the occupant mainly, right? For that, trying to understand the tacit knowledge, we need to deal with the knowledge systems and try to understand what data is, information is, and how it turns into knowledge. And as in Penrose, Roger Penrose, he inserts understanding between knowledge and wisdom. And for here, I need to see. Okay, let me take it to here. So this is how I perceive the architectural designer's identity through ages. That's from the perspective of the occupant, right? So in the nomadic age, it was the hunter-gatherer who's the occupant, and the nature was the designer. And then the agriculture, Neolithic age, it started, the occupant appears and changes the environment, starts to change the environment, right? And then not all occupants are producing the architectural space, but there is the architect who's becoming the expert of that expertise. So then in 1960s, we see still the occupants are the both ruler and worker and the avatar. And we start seeing the cities, the physical space, the virtual space in the information age. So in the industrial age, we see the cities, the ruler and worker type of the occupant, and there are the transportation hubs and homes and houses and apartments, and the technology is has a lot of controls over the expertise, right? So then the computer-aided architect from the 60s, as I said earlier, we see the file to factory, construction, robots, and computers. And this information age shows us the hybrid intelligence that is producing space, the architectural space. Before then, it's all biological, right? And then it starts being hybrid. And in the knowledge age, we see mixed reality. The file to factory turns into file to site. And we have the digital twins, 3D printers, construction robots. And we see the AI-aided architect since the 2000. And in the future, God knows what, but there's a prediction that it might be the wisdom age. The hypothetical wisdom age will have the galactic settlements, interplanetary portation space, and all the technology will be based on nanotechnology and biointelligence. Maybe the technology will be based on the programmable matters and microscopic, nanoscopic, and etc. Drones, and the avatar will be the occupant, and the designer will be the avatar occupant. And I don't know if we're going to be seeing that, but it will be non-biological. That's all hypothetical. But now that we're in this hybrid intelligence, and today we have the AI-aided architect, that's where we start trying to understand the occupant-centric approach that architects should take. Because if we want to understand the space creation, the AI-aided architect will, I guess, have access to that specific knowledge, right? Otherwise, the AI will be knowing everything. So that takes us into the occupant, the one who's going to be using this architectural space that the architect will continue providing, creating, right? All the other things, AI, machines will be handling. So what's left as beneath that consciousness, maybe, is the unique way of doing things. That's the local knowledge, and that is tacitly held, right? It's not explicit right now. So the knowledge to perform an act, but easy to explicitly articulate. So what Polanyi calls this tacit knowledge is we can know things and important things that we cannot tell. So we're going to be trying to get that implicit knowledge and try to make it explicit. Or if we cannot do it, we're going to keep it in that latent space, right? So music to architecture is what we call this model that we prepared. And we're going to be, as a research team, ArchiRobie Labs, we're going to be working on this, the music to architecture for a while. And it might be, as a continuation, it might be the other dimensions of locality, which are locational, geographical dimension, social dimension, and temporal dimension. And music belongs to all of them right now. So coming back to what AI is, it's a set of techniques used to try to imitate human intelligence, right? When we say AI, in this workshop, we mean that it's a way to imitate human intelligence. So AI may be referring to collective intelligence that keeps learning from every computable source that we as humans cannot reach, attend, comprehend, and or process individually. So that's how AI is handling a lot of things. And this is the perspective we have about architecture. Since we know a lot, we have this experience of creating space. It's a collective experience, it's a collective knowledge. But this collective intelligence that AI has keeps possessing and keeps feeding with all that capacity that it has, we might be seeing this collective intelligence that now we need to learn from AI. Google AI, OpenAI are the maybe the pillars of this space right now. Google AI is working on AI skills into one giant network and understanding jokes, answering complex questions, Dr. Alan Thompson calls it. And they're working on understanding jokes because it has that consciousness that is hard to pin down. And OpenAI, again, their large neural networks might be slightly conscious. Ilya Sutskever calls it. And this is a question mark, whether it's going to be called consciousness. But we see that the bigger it gets, the maybe more knowledgeable it will be called. And we need to differentiate these terms, right? So if we look back to the recent changes, but in the last century and within the last decades, the expert systems were predefined by logic systems, and they were coded, they were programmed, right, based on the rules that were explicitly defined by the experts, and they were implemented in the machine learning, but they were not really learning, right? They were rule-based, and you would give the input and plus the rule-based, and then you would get the output. But in the learning systems, we have identifying patterns from data, and that's how it works. So it's not coded. We either give the input as labeled, we call it supervised, and we give the output, and we say this is called this, this is called this, and it comes up from that pattern. It comes up with the rule base. And in the unsupervised, we're not even giving the output. We give the input, and it's unsupervised. It comes up with the rule base by itself. So from complexity, from simple rules, we can come up with complexity, but it's not anymore an accumulation of simple rules. It creates links, and there's an inherent understanding of those links, and it's not the simple rules anymore that it has created. That complexity is not a compilation of those simple rules anymore. It has some more added to that. And fractals, for example, they're the basic patterns repeating at different scales. And are they computable, incomputable? Is there any consciousness of any type between those simple rules that are creating that complexity? We're going to be looking at that. So there's this machine wisdom that I would like to share with you. You can just, if you haven't seen it yet, it's like the this person doesn't exist .com. This is the machines wisdom .com, and each time you refresh it, it creates words of wisdom, right? Here it says to be great, make others great at the same time. So that incomputability is what we're after, as I repeatedly say. Whatever consciousness is, it's not computation, Roger Penrose says, and that incomputability, the latent space in architectural design process, we're not, it's not a common way to define tacitness in architecture, but since we're also dealing with machine learning and we all understand, or if not, please let us know, the latent space in neural networks, in artificial neural networks, right? So the tacit knowledge underlying the performance of architecture is incomputable. In other computational design endeavors such as shape grammars, as I said, the expert systems, they are the rules are given by the experts, but there are things that reside in those outside those simple rules, but within that complexity, right? So not all parameters can actually be pinned down when occupant is considered. So as we say, we call occupant, it's the humans that we're trying to understand and design for. But through data, we can reach a stream of knowledge that transforms itself within different patterns. And generative models in machine learning have the potential to learn from the natural features from data sets. And these features may be based on any type of classification or maybe on something we have not uncovered yet. In our workshop, we will use both local music and architecture data, and we're going to be trying to understand, to uncover that space. So how does the machine learn? I'm handing it over to Selen Hoca. And before, was I going to talk about this representation? Or you want to go? Okay.
Just trying to share my screen. Wait a minute, please.
By the way, do you have any questions, any remarks?
Yes, I have a question. I'm not sure I understand what latent space means. Hello?
1 minute.
Can you hear me?
Yeah, we can hear you. Just trying to reach the correct slide. Is this one, Hocam?
Ah.
Do you want to just introduce the license send, or
the representation learning is what we're actually trying to do, and for the ones who have not heard about machine learning earlier, this most important features to capture from data, the features to map for visual generation is captured from data, as I called the pattern that the machine learns. It sees a pattern that we humans cannot easily see. It sees it from data, and that data is the important, is carrying the important features to capture. Okay, And the latent spaces are learning the essence. When we call latent space, it is within the model, within the neural networks, and we usually are not exactly sure what's going on there, but there's a lot of work on that explainability of that latent space. And we draw some parallels between the tacit knowledge of architecture and the latent space in machine learning. And when it's the learning from images, it is the representation of that image. And we're basing our experimentation on this knowledge. And the P nu is equal to P1 times 1 minus alpha plus P2 times alpha, and that will that we will be using, and you will start understanding how this works if you haven't already touched on that land yet. And this default representation, and it goes through deep neural networks, and those deep neural networks holds that latent space, and then it has a good semantic representation. You may also call it classification, right? That's how the machine sees that space, the data.
Yaron, can you get an answer for your question about the latent space?
Yes.
Okay.
Thank you.
So we will be using the GAN's generative adversarial networks with the complicated neural network architecture, basically. It uses two types of discriminators, which tries to discriminate the real images from the fake images that the machine generated. And with using that kind of an architecture at the output, we will be evaluating, the machine will be evaluating the fake and the real images, and so on. We will just see both the input, output, and the generated image, and we will see how the model was is it successful or not to generate those images from the given output. So we will be generating as a synthetic data that would be learned from an image to generate it through the music data. So this is the basic GAN architecture. So we give random noises. In this case, it would be our image data set. And we will discriminate it through the generator architecture as lots of deep networks, convolutional networks that both trying to understand the data and try to categorize it. And we will have a training set in terms of including the architectural images and both music data. And then we will start to generate, and the discriminator will tell us is this the output is real or the fake, as the machine continues to generate those instances. So we will, when we start to work on the code, the epoch value started to write down upon a certain loss function. When the loss function starts to decrease significantly, we can say that the machine works properly, and we will see as a visual output with it, like the output images as a plotted by the matplotlib library in the end. So maybe Özlem, you want to just give an impression about these examples?
So what we draw as a connection between music and architecture can be exemplified in the Baroque area. So the sampling of Baroque area, we have the art curved line and areas under erratic light gives rhythm to structure. Musical works show a tendency to have excessive decorations with their long and fluent melody and various rhythms. So there are definitions of these styles and areas, and they have some commonalities. You can go to the other one. For example, when we look up the hip hop music and architecture within the internet, just a short search, it gives us the music and these images about hip hop music and this architecture that is defined as the hip hop architecture, right? So that parallel things within the music and architecture within an era or a style is, I'm sure, interesting. And we have another one. Okay, so now it's again what our model is pretty much like this one. This is learning from videos, and it's called speech to face. So it can, with such a model, you can, the machine learns from videos, and then it learns the how that speech corresponds to that image, and then from the speech file, the speech data, it can create the spectrogram. That's what we're going to be doing. So it turns speech to image, actually, speech to pics, we may call it, and then pics to face, right? So it is a multimodal model, and that's an example of a similar example to our model.
So, in the slides, we will ask you to choose your local region to work on it. So since during this workshop, we prepared a data set and we will share with you guys. But in order to understand your localness in your current region or your random selection of a location, would be appropriate to choose and drive the data set from the internet. So you will be through this workshop understanding the selected zones locality in terms of the vernacular architectural instances. It might be your home city or home location, and from that location's original local folk music. So at this point, we would like to give some time for you in terms of a breakout session, or just you can leave a break, and you can think about it, in which location can you work on, and which data that you can drive from this location. So, and the upcoming session, like in 11 or 11:30, something like that, we will be discussing how we can translate this data into the usable formats in terms of the file format and resizing, renaming, etc. The data preparation process will begin afterwards. So we would like to think about the geographical region that you would like to select and work on. So you might just work on with the data sets that we have provided for you. But in terms of like making a research project in terms of under the scope of the local intelligence, we prefer for all participants choose one location and to start to work on. So for the break, what should we say, Hocam?
Yeah, 10 minutes is good, I guess.
Okay.
And as Selen Hoca told, it's not obligatory that you pick a place and prepare data, but you may want to do that. We already have the data set for you. Okay, see you in 10 minutes at 11 at our time. Yes, 10 minutes.
10 minutes. See you.
See you. So I would like to remind our participants that we haven't started from the very basics of machine learning, but from time to time, we're going to be explaining in detail what we're doing in our models. And also, since the Digital Futures platform has a lot of information, they're all recorded and you can reach them and in several subjects about machine learning and AI and how AI in architecture is improving. It has a lot of work that is going on, and they're displayed in the lectures and workshops of Digital Futures channel. So please try to follow that that platform in terms of improving your knowledge about artificial intelligence in architecture, and at very high speeds it develops. So that's why we did not start from the very basics. But again, if you have any questions about understanding the basics of what we're doing, please don't hesitate to ask. And for today, we have one thing. I might not be hearing what you say if it's not in the chat box. Since Selen Hoca and me are in the same room, I turn off the volume of my computer when she's talking. That might be the case. So just ask again, okay, if I haven't heard of it. Okay, so Selen Hocam.
Okay. Can you hear my work? Okay. So if you talk about your selected region, we will directly start with the data preparation process. So in terms of data preparation, we will learn the open source data platforms that we can collect data and the basics of data scraping from web and data crawling methods and software to batch processing to download images and both the audio files. And we will process this data into the usable formats in terms of file formats, PNGs, JPEGs, MP4 files, MP3 files, and more. And we will, at the end, we'll show you a database to conduct a systematic research to collect the data in terms of the correct labels to use in for the future research proposal. And we will, as we also had, use on Colab, since all the libraries have pre-installed in the Google's network. And we will additionally use an Octoparse software for data crawling purposes to directly download the images from the web without clicking each image and save image function. We will just process it and to download tens of or hundreds of images at the same time. So we will be looking at that. So before we start, it is important to note that the data is the most essential part of the all machine learning algorithms, because you train your machines with your collected data. So the most important thing for the data part is to find the data that exactly corresponds to your research question. So it doesn't matter, you can just provide the data in all formats. It might be TIFF or JPEG. We can convert it with using the prepared codes for that. But the important thing is to just collect the usable data in terms of your research proposal. So I will show you a couple of open source data platforms which will provide prepared data sets in terms of like the image and both audio. You can just get benefit from them. But in terms of the scope of the local intelligence, it might not be enough to provide you with the labeled data sets that we are looking for in terms of the geographical regions. So one of these open source database platform is the Kaggle. Kaggle is kind of like if you're a designer, you would just from your background recognize the Pinterest as the most creative source for the architects maybe, and the Kaggle is the platform for the data scientists basically. You can just visit the site. So you can see my web browser screen or the presentation page. Okay. So Kaggle is like a data set provider and also like a data set competitions also handled in this platform. You can just sign in and see lots of competitions or going on in terms of like the coding skills and collecting data sets, etc. But we will be mainly using the Kaggle for downloading the data set. You can type anything in terms of you can find CSV values or Excel sheets in terms of data with labels on. But for our case, we will look for mostly the image data set. Therefore, I can type like a architecture image, the basic keywords. There are also prepared data sets for example, Cypher 10. This is used for object labels in terms of the cars, birds, and deer objects to classify it using the deep learning algorithms. There's also a paper related to that. There's a like object recognizing GAN algorithm with using the CNN modules in the end. Or maybe we can just look at the one architectural styles data set. There's tons of images in different folders named as in different styles. For example, the Art Nouveau architecture, it has 450 files that you can directly download from this folder in an archive. And you can see that there's lots of images collected and this data set. So you can also search for other data sets, which I found amazing to download it in one hand. So Kaggle is an ultimate platform where you can search the data. So, okay, I'm just turning my slide back. And there's also another open source platform that's called as Papersheet Code. As you can see, Cypher 10 is also located up here. This platform provides you both the data set and also the related paper where they did use in terms of training their machines for different purposes. For example, MNIST is one of the key sources for the data applications where you just type in while writing the numbers and the machine recognizes the scripting pattern of yours in terms of interpreting in the numerical outcomes from the keyboard. So for example, you can just search for it and see the outcomes of it and the related papers in terms of, it has the GitHub code related to that. And you can use this dataset loaders in order to get the data set. Okay, and another one is ImageNet.com. It's also like have millions of data sets inherent in that. It is one of the projects. It's called as like the again labeling the data. They have provided a tons of images to label it in the correct responding to their names, labels, etc. And a case, also the Columbia Imagining and Vision Laboratory is created by the Columbia Institute of Architecture, as I recognize. So you can just search for different data sets that you can use for other purposes as well as this workshop. These old papers and the related data sets are linked on down below. So this is all for the basic information in terms of the data knowledge. And also there are a couple of like the open platforms that called as open image data sets. That is like exciting. You can search for all the Google images available in the open source network, and you can just type in a random category or name, and it directly labels that object and classifies it into the correct responding. So I can search for maybe a deer, or just search from this one, binoculars. It gives me a tons of images, and I can download from selecting from here. For example, if you're curious about specific objects, you can type and search for this data set. Okay, and the TensorFlow. TensorFlow is also a provider for the GAN algorithms that we are using for the cycle GAN mostly. And Pix2Pix is also related with the TensorFlow. It's also like the code developer, the library developer for the Python, and it also like gives some sample data sets for to use in that algorithm. For example, you can see lots of images, ImageNet. It was like the one we saw before, the naturalist data set. It contains like these images and it labels automatically. It is a growing open source platform that you can search for the data as well for different purposes. And for our case, as you have also seen the previous examples, there's more general purposes for the machine learning examples. They can provide the labeled data sets in terms of for the supervised learning purposes. But in our case, we will search for the local data. Therefore, we cannot reach a direct source from Kaggle or TensorFlow into the specific data that we're looking for. So we might have to visit the local blogs, magazines, or newspapers, or even Facebook groups in order to reach the vernacular instances of the selected region in terms of architecture and audio. So if you have selected one region in your mind, you can start to look for the data where you can provide it in terms of both websites and all the dataset platforms. But I'm thinking that you cannot be able to find the prepared datasets in order to download. So we will look after the data scraping and data crawling methods. So these terms both use in the terminology as getting a batch process of data at the same time of hundreds and tons of images. So data scraping works from generally an HTML endcode. So if you just type in any website and inspect the web page, you will see the HTML backend. And you can directly copy from that code and search for the related Python code and directly download the data. But this is a more complex project that you have to have a coding skill in order to gain it. And in this scope of the workshop, we will use another interface that we call the data crawling, which uses software for the same purpose. And we will begin to deal with this data crawling tool that's called Octoparse actually. But in order for you to have a basic information, data scraping allows us to extract data from various sources, including web, but also the different TXT files or Excel files, etc. But data crawling is mostly upon the website. And data scraping can be done at any scale, but the data crawling should be collapsed within a scope of a research. And from data scraping, you can just directly detect the images that is duplicated in your data set. But in the data crawling, we have to eliminate the duplicated images, and we will need a crawl agent, which is the Octoparse in our case. So we can just click the Octoparse, and you should also click it. I will just copy the link below and start to download the software. I can just share this from the chat. If you just visit the site and start free trial, we will just use the free trial mode and log in. You would see the Octoparse interface when it's downloaded. And you will try to search for the images and directly download all images from that platform. So I may give a time for that purpose, or should I continue? What do you say?
Give it time.
Okay.
Have a look.
Just to download the software. We will be back in 5 minutes.
Yeah,
5 minutes. Okay. Do you have any questions by this process?
So we should just download Octoparse.
Octoparse, yeah. I just copied the link below, and you can just start free trial and make a login with registration with your email and password. It is easy to use. Also, just started new, but we will see it in the previous in the process. Okay, so see you in 5 minutes then. Okay. Did you download the software? Has anyone any problems according to that process? If you have any questions and you won't like to open your microphone, you can also write it down through the chat. So if everyone is ready, I can just share my screen and go. Okay. So you should see my Octoparse interface. And I will just go to my Chrome browser or whatever you use and search for the data sets from there on. So in terms of our data set scope, we will just search for the local architecture images of the Asian region in terms of the Turkey, Bulgaria, and Greece. So I will follow on the same steps to reach that architectural style. So I will just type basically Asian architecture Izmir, which is in my hometown. And from the Google images, I can search for all images. But as you can see, there are a couple of instances that we are not looking for actually. So I can just select one related photo, and in terms of there's a couple of images related to this one. I'm sorry. And if I just click on to view more, I can have a screen full of my instances. As you can always click and save the file, we will use a batch process for the data crawling part. And after I just found the correct page that responds to my research question needs, I just copy the link and open the Octoparse and paste the link down here. And Octoparse would automatically detect the web page to search what we are looking for in terms of, it might be the images or the labels or the URLs related to that, the names of the files. And as you can see here, it's completed the scanning the page and found the field, the title names, and the URL. But right now it doesn't give me the image labels, the image files. So I switched the auto detect results, And here it gives me the list of the images. So after that, I just click to create a workflow. It directly give me a loop data in a like a Python code, but it directly goes to the web page and scrolls the page and extracts the data. It's a kind of a loop structure in that. And I say apply. After, I just run. Okay, I just reach my task limits. Maybe you can just try with your own, because I need to open a new account to do that, because my free period is just ended. So I have to ask you for like 5 minutes, unfortunately, to start the process, because I need to log in into a new account. So sorry for that situation. I didn't check it before. So I will just ask for 5 minutes, not that last too much. So, do you have an account? No, I haven't. You can just register for a new account and follow from that.
Excuse me, I have a question.
I'm listening to you.
Sorry. Let me send this artist. His name is John Cage. He gets a communication about music and Chinese regime. So I'm thinking about is there any possible AI can get a deeper recognize about the marks, the music marks as let me see. I will send you some the link maybe. Let me see.
Okay. I didn't quite get the question, but what do you mean by the mask? Or did I?
That means the. Let me see. The music notion. The music notion. So let me send the link here. Yeah, here it is.
Maybe our other instructor, Mustafa.
iTunes. That means iTunes.
Mustafa, can you help with the Jingo and Tal and I process with the Octoparse?
Okay. I will just check the YouTube channel.
Okay.
He just sent. See what this is.
Hey, Selena, I have a question too. So
John Cage music named the music of changes. Get the relationship between music and action.
I didn't get the question, sorry.
Is that possible?
I
can
didn't
read.
ask it.
Is it? Sorry, is that possible? You can get the means from the wiki page.
No, I was just watching
I sent
the
it.
YouTube video.
I sent the link.
You just sent, and now I'm like.
Just a minute, I'm just checking the link that Jingun has just sent us, and as I see right now, only the one image in the Wikipedia, but we are trying to reach multiple images at the same time. So it might be like more beneficial if you just search for a image database some kind of a newspaper, it might be, or blog paper. It doesn't matter the resource too much, but since we are dealing with the images, so it might be useful to search for a more giant library. If it was your question, I'm not so sure that I just correctly get it, but
can I send the image? Maybe it's much more clear.
okay.
Let me see. Just a second. iTunes.
Oh, okay. Oh, I see.
Yeah, what was your problem, by the way?
I just wanted to ask, after inputting the link into Octoparse, because I was downloading it while you were explaining it. So after we input the link into Octoparse, and then I'm not really sure what to do.
Okay, I will just show it afterwards because I have signed in. After the chaos problem is just resolved, I will continue.
Okay, thank you.
Okay. So your question is related to labeling the musical data then?
Yeah, maybe some data can get the relationship between iChain, the Chinese iChain.
Chinese item.
Yeah. Here, I send the image. Here.
I see.
John Cage get a music show named The Water Walk. In 1960.
I'm not familiar with the John Cage name, but I think he's just experimenting on this item in terms of audio making from that text.
So no, it's just like a similar thing. What we are going to do here, or what we are going to try to do here. He just find the connection, find the relation between some cultural context and another one, the music and the another context. So
yeah,
we are not going to try the same thing. We are not just going to try to create the music from like some another cultural context, but we are going to try to create architectural image from music, or the music from architectural image. We can try that too, of course, but we are going to try the similar thing.
Mm-hmm. Okay, I get it.
Okay.
Yeah. Okay. Thank you.
So I can continue with the data preparation process. I'm just sharing my screen again, and hopefully it works right now. And I have just click on the Octoparse again and copy the link. The process is same. We should give it a little time in order to parse all the web page. And it detected some labels in terms of image URLs, the titles, and the website related to them. And at the bottom tab, you should see in this field an image, but as you can see, I cannot see it right now. So I just click switch the auto detect result. So here, the image tab is appeared. So I just create a workflow when we found that the images are labeled through the R file. So I click. So here, as you can see, it gives us a loop option, which is whether we just click on the Google images and click on each image and click that save image, it does as a loop function for us to download more than one image at the same time. For example, all the red labeled images are going to be downloaded as we continue with this process. And I say apply, and I say run. It gives me the two options, which one is the cloud option in the softwares of the Octoparse, but we will run our code in our device. So I just check to run now. And it will automatically start the task. And it is extracting the data, as you can see. And it has completed the task. It has 34 photos, the lines as, and we can just click the export data. We will export this data as Excel file. And I just rename it to you can type in whatever you want. And I just open the file. As you can see here, I have all the image URLs and data. And I want Excel sheet related with their names, etc. So I'll copy this row. And using a Chrome extension, I will just download it. This extension have multiple options. You can search for the web, but I use the tab save in Chrome. You can download it instantly. It doesn't take more than 1 minute or so. And when I click this pencil image and copy down the code, it directly start to download the images into my destination folder, which is my downloads. As you can see here, all images have been downloaded by using this Chrome extension. So you can whether copy it into a certain cluster file folders for that by Control X and Control J to your file destination. It's basically like that. So do you have any questions related with this Octoparse thing?
Yes, how do we extract the data again? I did everything until
Okay.
like the end, but I don't know how to extract the data.
Is it possible for you to share your screen? Maybe it's
Yes,
better that
yes.
way.
Can you let me share my screen?
Okay.
Okay, I think it's
Please train again.
So yeah, can you see it?
Yeah.
So I got my page. I did the scroll thing.
But you
and
don't have the image line right now. So maybe just trying to the little orange balloon at the top, which has the light
Yeah.
bulb in it. And you can just, you don't have like auto detect option. So maybe you can click back into the first page that we just type in the Google link, not the Google first link. So you should also like Catalan modernism architecture, you could copy it into your Chrome browsers, not in the Octoparse.
Okay.
Just
okay.
copy it into your
You mean
Chrome
this,
browser.
right?
Yeah, yes. Just type in
Okay.
the Google Catalan modernism architecture on your Chrome browser, not in the Octoparse.
Okay. Modern.
I cannot see that screen, but
Yeah, I was on my.
see. Okay. And go to the image and find the related image tab, and you just copy the URL at the top. Yeah,
This
that's
one.
one. The
Yes.
whole one, yeah.
Yeah. And
Just
then
copy
paste it.
to the Octoparse from the home page, please. No. The
Oh,
tab,
copy it here
Yeah.
and put it here
Yeah, and
and
click
start.
start.
Okay.
It should give you the auto detect option, but what is the problem? I'm not so sure of. Maybe.
Just loading, yeah, auto detect.
Yeah,
web page
yeah.
data.
Click on that. Yeah.
Okay. Yeah, it
Okay.
seems like it detected
You don't have like the still see. Do not click the create workflow. You should also see the image tab at the below. So you switch the auto detect result.
switch auto detect results.
Yeah.
Okay.
And switch
And,
again because you don't have yet seen the image.
And switch again.
And you have like the right now the image tab. That's the
Yes.
third option. Not you're on the first option right now. You should switch into the third option.
The third option. I see. This one, image.
Okay, yes, this one. So you can say create workflow right now.
Okay, okay.
Say apply. So,
Apply here.
yeah.
Okay.
And run the task at the top right corner.
And run test now here.
Yeah, or you can just okay. But it would just you can just
Or this one.
yeah, this
saying
one, yeah,
here,
this
run.
one, yeah, this one.
Okay. Okay, and
Run on your device.
Or...
You cannot see the old. Okay, it started running.
So what this is doing, it's extracting all the images that
Yeah.
it found in the research that is related to the title, basically, and it's downloading them
Automatically from the googleimages.com. You can use it for different websites as well as, for example, ArchDaily or the Zine. It might be if it's related to your research question. The process is same, and if you have any problem with the auto detect function of the Octopart, you can also manually interrupt the process while adding a loop structure into the window in the right corners, as we see right now. But for general purposes, you wouldn't have any problems related with this stuff, especially driving data from the Google image, because it gives you the without any sign-in or on any other options besides your Google account. So it would be easier to do that.
Okay. And I just let it run right now as much as it needs.
It scrolls down infinitely. You can pause it if you say that you have reached your enough number of data, or you can just wait a little bit to run that code. And after that, you will just export it as we did previously into an export file, Excel file, and copy that link into the Chrome extension that's called TabSave as I use.
So can I stop it right now?
Yeah, you can stop it.
Okay. Are you sure want to stop? Confirm. Stop. Export data.
Export data, yeah.
Okay. Remove duplicates, I guess.
Yeah. Yes, sure, because we won't have to have second images of everything. Okay, export data right now.
And Excel, and that's
Excel, yeah.
All right. Yeah, just save. That's it.
You can
yes,
just click confirm.
All right. Thank you.
You
I
can
can
open
start
file
sharing.
and yeah, okay. Okay, you can just stop sharing
Yep.
if you have answered to your question. Okay, then I will
Thank,
continue.
thank you, Selam.
No matters. If you have any question at any minute, please don't hesitate to ask, by the way, for all the participants I'm just saying for. You can also write it down through the chat or Discord, whatever you like. So I continue with the data process into the collab then. So there are a couple of important notes that I would like to mention before we start working on notebook. Right now, I will share a link that connects to our main drive folders in Google. It has the images and the audios that we have prepared for our model. So it is important for if you would like to train your machines with our data, download this folder and make a new folder in your Google Drive directory under your name. So for the notebook that we will share with you, this is all IPNB files, which is the Jupyter Notebook file format, which also the Google Colab works with it. So you can just download the IPNB notebooks and open in the Colab and start to run the code. We will just do it step by step right now. But the basics, if you have no coding skills elsewhere, the code will run smoothly without any problems if you just change the file path according to your file directories. For example, in our case, our file path was starting with content, drive, my drive, workshop 2022, datasets, architecture, unprocessed, blah, blah, blah. And if you just copy or upload your image folder into your drive, you should have directly copied that file path into the code, which would run smoothly. Okay, I'm just sharing the link with you guys. But I cannot see the chat option. Or can I read the chat? Şu an görünüyorum. Şu an gördüm. Can everyone check the link if it is working? Or you can just click on the image data sets. Maybe I just can show what we were looking for in terms of the architectural image data sets, what we mean, what we have collected yet. So these are the data sets that are generated by three of us in terms of the local architecture data sets. These are the images that we scraped from the net. This belongs to the Aksaki, Antalya region, which is the Mediterranean region of Turkey. So this is all Google image photos. This photo belongs to the Izmir where I live, where we both live with Laila actually. This is an Aegean city. It has strong connections to the Ionian background and to the First Ages. So this is all the instances that we have collected from the web. This is the versions that are unprocessed right now. So the file sizes in terms of the pixel range, it changed that drastically. And it might be also the format as BGPEG or PNG files. It doesn't matter since we will convert it right now. Oh, this is the data set that we initially provided for you guys. So if you would like to use this data, please click on the architecture data set and download the unprocessed image data set by downloading it and copy it and upload it to your new drive folder under your drive and use this file path as the original file path. For this workshop, I prepared another file for that. I named that trial. And I just uploaded my images into the, not this one, unprocessed image file folder. As you can see, these are the same ones. but this is the Excel file, so I'm just deleting it. So as you can see, all my images are uploaded at here. And right now I will just use my Python code in order to resize and crop the images. So we will try to reduce the file size in terms of the pixel size into the desired pixel ratio and try to maintain the maximum dimensions of a square, since we are training with our machines using a square formatted images. So this link, which I just copy right below, will guide you through the IPNB notebook that I was talking about, and I will download it. And here it is downloaded. So I switch to my Google Colab, type Google Colab. Do you have time, or should we give a break before we start to dealing with code? Or are you fine with the pace?
It's fine with me.
Okay, I just continue then. I have just downloaded the notebook, and from clicking the upload button, it should be written, since I'm using the Turkish version, it might be not familiar for you guys, but in the top right corner, you should see the upload option. And I click on the file, and I selected the downloaded image and resized cropped IPNB file. So all of you can see the code right now. If you just follow my steps, you should be seeing it. Did everyone was able to open the page?
Yes.
Okay, perfect. So first, we start with importing the libraries, which we use the OS and the globe library. Globe tries to maintain the joins the file paths of the options, and
maybe you may want to talk about libraries.
okay.
Why we use libraries?
Okay. So 101 for the data science in terms of the Python coding. This is actually the main reason why we use Colab. Python works within the downloaded library. So if you use another IDEs such as Visual Studio or Anaconda or whatever else, you should manually download each library that you will use it with your code. But since we are using the Colab, we just can drive the libraries from simple code, which we call import function from Google Colab. So for example, there are two types of libraries that we are using right now. The import else, maybe we can search for the Google in terms of IP. There are a couple of like web pages, Geek for Geeks, for example, to introduce you the OS module in Python with examples. It basically generates the paths and drives the files from the file paths into your code. It uses for that reason. It opens files and closes files and reads files, etc. And the globe library, as I said before, maintains to join the path locations. Example.
So we may want to iterate. I don't know if you can hear me. I start using the headphones. The library, we're going to keep using the libraries, and Seven Hocam, Hoca will keep talking about them. When we have to repeat a set of code, we don't have to rewrite them.
by the help of these libraries, right? That's why we call them libraries, and they are like a repository that we can just insert into our models so that we don't have to do it again and again. It has this predefined functions like make this, path exist. It imports it directly from that source code into your Python code, so we don't have to write it from all again. It is pre-coded libraries for the use of the single users. So I can explain maybe like that. I'm not so sure if it's clear or not. Let's just go on. So I just import my libraries from PIL, for example, for the use of images. We will import PIL library from image filter. And my code is working right now, and it's completed its action. And I will mount my Drive account in order to take files from my Drive folders. So it might take a while because it requests access for my Drive. And I say, okay. Unfortunately, you have to do it each time when you run the IPNB notebook. In each time it requests a certain access. My Drive is mounted right now. And I then start to define the central crop function. So this is the square image that we were looking for. So this is a definition where we call as a function. So I just give the parameters as image width, image height, and define the function as PIL image size. And it will give you the cropped image at the total width, at the cropped width, divided into two to get the maximum square out of a rectangle image. So this is the also predefined function of PIL library. So I just type the PIL image and return the crop center image, PIL size, etc., etc. For this process, you don't have to change anything from this code of the data, but you have to have change this file path in order to reach your data and write upon. So this is my search directory, which contains my unprocessed image. So I will change since I added into the new folder. So I'll just begin right away. So I click on the file tab at the top left corner, and you should see Drive. And I click on my Drive. And you should see a couple of folders. It directly allows access to any folder that I have in my Drive. And I click on Workshop 222, which is my file directory. And I just open images, not images, sorry, datasets, trials. This is my original file path. And this is the processed image dataset where I contain all the data, not the unprocessed one. Sorry. You can see the files that I just downloaded from the web. And by right-clicking into that, I just copy the path. You should see it by right-clicking in it. I just copied the path. So besides that, I'm just Control-C, Control-V. And for the destination direction, I just copy the file path of processed images. And I copy that path too. So for the first, I will begin with the JPEG files, and I just uncomment this code for opening the PNG file. And it would, at the same time, crop the images and resize into the desired thumb image size, which is decided by us, 200. You may want to talk about uncommenting.
Okay, so the uncommenting in Python works like that, giving that square
by typing Control, Shift, and slash, which is in most of the computers is upon the 7. So you can just like Alt, Tab, and 3 by commenting like that. Alt and 3 and just commenting a square. It works like if you just select one single line, you can just, you can just type into the beginning line of the Alt tab here like that, or you can just select the whole code and Control Shift 7 directly commented and directly uncommented. So the comment.
What happens if you don't do that? It gives an error while you're trying to run, because you tell the machine whether it's just text or it's a code, right? So differentiate, to let it differentiate. That's how you do it. Comment and uncomment.
So the lines that we write here defining the functional to crop max image is just to remind us what does that function do for us. So the machine won't read it while running the code. It only here for to give us information what about the code work. So if I just run this cell after running this cell, it would directly start to process my images, since I have already defined my functions and we call them in here in the for loop. It will give us a file path with the correct directory folder in the desired directory in terms of the process image dataset, and S title is the same with the original file name, and the thumbnail you can just write it whatever you like. I can call it Selam, since it has just like the commenting option with the 2 slashes, or I'm not so sure what it's called in English, John. The üstten parantezi. Yeah, you see that like this spelling. I'm not so sure how I just pronounce it in English, but you can type whatever you want in this like text function. Close, yeah, maybe. So I just run that code. As you can see right now, it is working. We can say printf or print file, that will give us the new file directory. And I will just check if the whole process is completed or not. I'm going to that folder, and the process image, as you can see, there are tons of images resized into the squares right now. So this is the first step, that how we deal with the data that we have scraped from the web. So do you have any question at that point while running the code or with the images, whatever it is? So yeah, Ivan, is there any problem?
Yes, so I connected my Google Drive in the beginning. Yes.
Okay.
My
Maybe you
Google
want.
in the beginning, and I copied the path for the source directory, and then how I love. Yeah, I will share my screen.
Okay.
Yeah, so I'm here.
Wait a minute, I can see your screen right now.
Yeah,
the internet connection maybe.
Pressing play again. Oh, yeah, okay. Can you see it?
No, unfortunately not. Hocam siz görebiliyor musunuz? Right
No,
now I
it
can
can.
see it, okay. So you run the first retrieving the data from the Google part, okay. Did you give access?
It's frozen.
Benim bağlantı. Am I lost
No,
in
no,
the
no,
connection?
no.
Okay.
The screen is frozen.
Okay. So Yarman's connection is low, I think.
My internet like went out and like,
Can you try to reshare it?
yes, I would. Yeah, I think I'm having some problems with my internet.
Might be.
I'm gonna turn off my camera with my other phone so
Okay.
it's less.
Okay. So
Okay.
you're driving mounted right now. There's no problem. You should run the first.
Now,
Okay.
okay, now it works. This wasn't earlier. Yeah. Okay, cool. It
It might
works.
be
Thanks.
because of the internet connection, basically.
Maybe. Yeah, maybe. Okay, thank you.
Okay.
Thank you.
So if everybody is just ready, we can just go through our slides to the next step. Are there anyone with problems in terms of collab or something? The notebooks, etc. So if you have, let me know.
I'm okay here. Everything
Yeah.
okay? Yeah. But
Uh,
it's based on the without a GPU or TPU, right?
I can't hear you. I'm sorry.
It's not based on the GPU or TPU.
It doesn't matter right now.
Okay.
We
No,
prefer to run in the GPU, but right now for the just cropping size, it won't matter for that part. But in later, we will use the collapse GPUs for the virtual learning process of the machine.
Okay.
We will manage it afterwards this session, so don't worry about that. Okay. What was that? So the next step is dealing with the audio data sets collecting from the YouTube. So for this part, we will directly copy the URL from YouTube into the text file. And from using the Python code, it will read out our text files URL and directly download to the audio files in MP4 format. So for this purpose, we will use the library called PyDub. Maybe we can just go and look for the results. So it gives you the basics of how to open a WAV file or MP3 or slice audio, beginning, etc. It gives you documentation how you can imply the library and how you can call the functions as you deal with the code. For that part, I will just copy that file too with you guys. As we have did before, you just can download the IPNB notebook and upload to your drive, as I do right now. I say, open a notebook, upload, select the notebook that I just downloaded. And here it is. Again, we will mount our drive. I'm allowing. And while it's working, I can just instruct how to do it. So in my drive file, I have a text file which contains the music URL. So let me just show this text file. Here it is. This is the YouTube file. You can just go for the YouTube and search for the playlist basically. I just for this purposes in the scope of the Mediterranean and Aegean region, we call it Jampetiko music, which contains both Greek and the Turkish songs. And as you can see, there are a couple of songs that both have like the Turkish instances and Greek instances in here. And if you think you have like you have found the local music source, the playlist, you can just copy the links into a new text file. Notepad. And copy that and start to just bring your URLs into that file and save that text file into your drive and read it from there. So after mounting my drive, I also installed the library called PyTube, as I said before. It has imported. And again, I will just give the file path of my text file, which should be the same, but I'm just checking if it is correct or not. Bookshop. Sorry. I might have to close audio.
Sorry, Selen.
Music. Yep.
How do we upload this YouTube, like the new file into the? Do we do it into the same Google Colab, like the one that we have? Do we upload it on that one?
This is the thing. Did you upload your photograph, the previous step, into your Google Drive?
Yeah, that one I did, and now
Okay.
for the
You can open a new folder for the music file and copy all the YouTube links into a notebook, for example, like that. I can just save it and upload it to my drive directly, as you usually do, and take the file path from that tab. For example, my file is located under the workshop 222 music, and in that music file, I just see the music dataset takes the file, the text file.
Mm.
So I just copy the path, and again, I will just repaste it. It would directly start to download all the music files into that folder. So,
but what I meant is, how did you open again this this code, the YouTube audio scrapping in Google Colab? Is this
okay.
like a different?
Okay. You should just
or is it on the same
click
one?
in the link that I copied in the chat. The second link that I just copied in the chat, the drive link. This one, I just click on again.
Mm-hmm.
And you should be able to download the notebook.
Oh, I see.
And upload into the Colab as opening a new notebook, Control-O. And you should upload it from selecting your file into your destination as the previous process. Okay?
Yes.
For this process, I do not want to interrupt a file one more, so I will open a new file to download the new music dataset. And I will also open it into my child folders, and I save as YouTube. I open the new file. My music dataset is here. I'm sorry, I just lost it. So I just copy the music set from this file location and change the save path into. I need to just remount it since I uploaded a new file. YouTube, copy the path, and from the phone I will paste it. And when I just run the code, it would print the video object, the necessary information for us, and while it also downloads at the same time. As you can see, this is all the description of the audio files that we are downloading. How much minutes that those contains. Are everyone able to follow that steps? Are there any problems? All right, now you should be seeing the downloaded MP4 files in your file folders, destination folders. Here, this is all downloaded files from the text according to the corresponding URL. You should be seeing if you just completed running the code. Or it might also be running, but I see the downloaded files right now. It would take a little while because it downloads directly from the internet. But as we see from that part, the code is working without any problems. And it's still downloading new data from the YouTube. We can try to
question just to be so just
Yaron, what was your question?
Yeah, so we're doing these two steps right now. We're basically creating the data set, the image data set. On one hand, we are like converting all our images into the same size image. And on the other hand, we're using also Google Colab to download all the related music that we found online in a YouTube playlist. We're downloading them. Okay.
This is just the data preparation part, not the machine learning algorithms have been started yet. Mustafa will show up the ways about the CNN and Gaussian algorithms. I'm just telling how you can drive data from the web instantly. As we all know, you can just directly convert all the images from YouTube by using the auto-generated converters called like Save from Net or something else. But you have to do it one by one. But instead, we use a Python code for batch downloading all these files in our text format. So it is easier, it is convertible, and we will just process it into the subdividing into the audio clips and converting into the WAV format, which is another audio format that we will just maintain our audio classification files. So do you have any problems related with this part actually? The YouTube audio scrapping notebook or the previous one, cropping and resizing the images? You can just ask the questions. For example, the code is stopped and this is an irrelevant mistake that the code gives us. It doesn't matter since we have just downloaded all the instances in our text file. We can see it. For example, just trying to select all. We have 84 files. And in the later process, we will divide it into the subclips and convert it to WAV format to generate the audio classification images. So if you have no question right now, maybe we can give a little break to process it a little bit in terms of downloading the data and convert it into the desired format. And after the break, we will continue with subdividing this audio clip that we have just downloaded and convert into the WAV format from MP4 file. And from right now, Mustafa is just dealing with the main collab notes where we would also see the machine learning algorithm, the pix-to-pix, and both CNN algorithm into that same notebook. So this data preparation is just like we are in the middle of it. If you have no questions, we can give a 15 minutes break maybe, Hocam.
Yeah, 15 minutes is fine, I guess. We're a little ahead of our declared timing. So I think 15 minutes is fine. And please, if you're left behind, if you couldn't follow, please let us know.
Yeah.
Don't stay silent. We can help you out. Okay, and maybe you may want to try during this break, and if you're having any problems.
By the way,
running this, you can let us know when we start.
I just forgot to share the manual. We have provided a manual for you for the data preparation process. I just share it with you guys right now. Şu an paylaşıyorum hocam. Paylaşmayayım. Açtım. Here it is. You can also, sorry. This is the copied link. I'm just copying again.
And for the ones who are going to be watching it afterwards due to the time zone, we may put them down on the YouTube.
It is in the Drive folder actually, but we can also share it in the YouTube file. As you can just clicking by the link, you can access it to that folder or from the general Drive folder, which you have an access from this one. This is our main Drive folders. I'm copying the link below, and I will share the link in the Discord as well. From that file, you can just click onto the process and find that manual here. It gives the basic info, the steps that we have just followed. Here you can have the codes written in the text format, or the codes also available inside of the document. Here
You are not sharing the screen if you were showing something on the screen.
Okay, sorry. So I was basically showing the document that I just provided a link for. So here the folders, the file. So this is the manual that I have prepared for data preparation part. You can just copy that text, or you can just click here and direct access to the codes that we have just previously used. This is like a manual for you to guide if you have any problems during the process. Okay, so see you in 15 minutes at 45. 12:45 for us. I'm not so sure for your time zone, but see you.
Okay, see you.
hello. I'm trying to see whether we have any change in the number of participants in newcomers. I'm seeing Arefe. Are you new? Arefe? Okay. Okay, so I guess this part. Hi, would you like to introduce yourself? At the beginning, okay, Yarvan. So at the beginning, some of us introduced ourselves, Arefe, and I think you were not with us at that time. If you like, you can introduce yourself. Yeah, I've seen his or her name in Discord.
No pressure, but if you want like to introduce yourself, we will be glad to welcome you.
Yeah, you can start your video and talk.
Hi. Sorry, I'm late. I'm from Iran, and I'm studying a master degree of technology of architecture at the University of Tehran. And nice to see you all here. And I'm happy to see you here. Thank you.
Thank you. If you just show up late, you can view our YouTube record. We will just upload it afterwards this session ends in our YouTube channel. And we will provide the link for it in the Discord channel. So I want to also ask, has everyone in this Zoom session access to our Discord channel yet? So I just copy the links from that channel as named as ArchiRobie Local Intelligence. Okay, that's fine. So you can just rewind yourself the first processes that we handle with the data scraping from web in terms of image and audio. And right now we can continue with the audio clips by subdividing and converting into raw formats from the provided Google Colab files. Mustafa will guide you through from that process on.
Okay, I'll just share my screen. After you downloaded your audio files into your Drive folders, I will just share the Colab screen. Actually, at first I will just talk about the Colab. It's like online idle, as Selam said, idle for Python. And if you don't have a good computer, like a good GPU or GPU at all, you don't worry about it. Colab will provide you GPU to run the codes of you developed. Here we can see the RAM disk part. When you when you use, you can see the system RAM, GPU RAM, and disk amount you use. And if you click the change the working time type, you will see that GPU, TPU, and none. And if you choose the GPU, it will just provide you some GPU for working. Initially, if you just click connect the work time, it will not give you GPU. So you have to change it from change the working type part. Other than that, when you just as Selen explained before, mount your Google Drive to Colab, you can access from this part, like here, and you can see all the folders, files in your drive here. So for converting MP4, MP3 files to WAV, we will just use PyDub. We will just some libraries in Colab is not installed initially. Most of the libraries are installed in Colab, but some of them are not. So if you want to install the library, you just write this like pip install. This pip install part is like Python's feature, and this is the library name. In your local computer, in your local idle, you don't have to use this part, and you just write pip install PyDub. But in Colab, you just have to write this whole. So okay, I will just continue. This import also part 7 explained that, and this MP3, MP4 files actually both MP3 and MP3 and MP4 files are same as according to Python. Actually, just changing part is the one of his the sound file of the video, and one of his just sound file. So we can just use the same algorithm here to convert them to WAV files. In our work, we are using mono WAV files, like single channel WAV files. Actually, normally WAV file has 2 or 3 channels, but we are just using mono single channel WAV files to convert them easily to spectrogram images. Okay, so here this part is the file location of your MP3 or MP3 or MP4 files. This is the file location of your MP3 files, and we are just creating a array list from there. And the destination folder, it will be empty, or it will be already there will be some WAV files. It doesn't matter. Destination folder where you want to save the WAV files in your drive folder. Or if you are going to run in local, you can use some Jupyter notebooks in your computer to do this process. So this part, this part is like just renaming the file. Like one of them is like at the ending is a .mp3, and we just want to replace it with .wav to just rename it. And this part is the converting the mp3 file to single channel mono WAV files, and just exporting to the library you just identified here. So when you just run this part, it will just give you this. Okay, I'll just go music and WAVs. Yeah, it will just convert these MP3 and MP4s to WAV files here, and then after that we will just try to split them, because it's like 3 minutes, 4 minutes, or 5 minutes things, audio files, so that we just want to split them to the like 30 seconds. We initially create 30 seconds parts of the songs to increase the data, actually. But if you want, you can just download lots of sound files, and you don't have to split them. But you can work with like 100 songs, and when you split them to 6 parts, you will have 500 songs, 500 data actually. So we split them to increase the data. This is the your single channel WAV file locations in Drive, and this is the where you want to save the splitted files. This part is again just creating the list for array to turn the loop here. I'll just explain it right now. Okay, so we are just defining times period for splitting them. We just created 30 seconds, 6 parts. You can just increase or decrease it. You can just arrange it like 45 seconds parts, etc. This is on you, and this for loop is like just doing all the same, all of it together at one time. We are creating a for loop for E in range length of WAV files folder. This WAV file is the array of ours. Like it contains all of the WAV files in the source location. So when we just created for loop for every length of the our data, it will just create, it will just turn the loop and split every sound file here to the split WAV files location with splitted version. When you just run this part, and you will have this kind of image, like this was together at 7 of them together, actually a normal single song. We split them and created 7 data from it. After splitting WAV files to parts, here comes the spectrogram part, and these spectrograms are like signature of songs. Like it will look like this. Yeah, okay. It changed with every song, and you can create spectrogram representations of songs, and it will be unique to every file, so that for these are just the libraries it uses to convert them. Like Librosa is a sound library creating spectrograms and turning spectrograms into sounds again. And this IPython display and Librosa display part is just showing the convert spectrogram images for us. Here is again just converting all the files in source location, like audio fpet. There's a source location of splitted WAVs, and here this is the im.save part. This is your destination folder, and this is your wanted name. Like we are naming it here to just to be clear, same name as the song's file name, so that we know that which spectrogram is belong to which song. I will show this in a single part. Here you can see when you just run this, it will just enter the splitted WAV file location. It will take the 15th song, only the 15th song. It will just create the spectrograms of it. I'm just running it, and you can see like this is the name of the song, this is the spectrogram file, and this is the resized. We are just resizing it because we are working in the, I will show it later, but in the pix-to-pix algorithm, we are working with square images, so that we are just resizing the spectrogram files into square images. This commented part, we will show it later. For now, it is unnecessary, but after creating spectrogram files from architectural images, tomorrow or the third day, I don't know, this part will convert the spectrogram file to the sound file. So we can just listen what will be the outcome of the generated spectrogram file. So this is our spectrogram file. We will use this one. Or you can just create another spectrogram file here too. This is, again, same library, but this is the amplitude spectrogram file. These are two different things. This one here, we are using mass spectrogram files. Mass spectrogram files are like mono spectrogram files, and we can just convert them easily to sound files again. This one is a amplitude spectrogram files, and it is more tricky to convert it to again to sound file. So you can choose any of them to work with, but if you just want to convert the spectrogram files back to sound files, I recommend this mass spectrogram version. So here,
Mustafa,
yeah.
at that point, maybe it's better to introduce them. What is this spectrogram and what we use for? Because since we are dealing with the audio, it needs to be somehow visualized in order to drive a data for the pix-to-pix. Because pix-to-pix is
Okay.
image-based algorithm that directly translates one image to the another one. So it should be somehow in a format that the machine can read it as a visual manner. That's why we just translate the audio files in terms of their notes or like the amplitude, etc. Within this information, it generates us an audio spectrogram, which gives us a availability to classify the music files in terms of a visual image. So, and before we begin to train our machines, I would like to interrupt one more time because I just forgot to show the participants about our database that we have collected for both the image and the audio. So as I begin, maybe you can just share it.
Okay, so
it should be in the databases folder.
this one?
Yeah, this one. So in the previous part, we have collected our data from web scraping. And as you remember, in Octoparse, we have the titles names according to the object. In order to keep research as a systematic one, we would like for you to contribute our database in the same format as we do right now. So for database folder, we have just opened a Google Sheets file, which you can have access to the both image and audio data. And image sheet, you can see the file names and the location of the photographs where it is taken from, as Turkey, the main country, and the cities. And if you have the location of it in an exact district or region, you can also note that. But unfortunately, in each data, we cannot find all the related data. It doesn't much more important, but in order to keep this database as a systematic research conducted, it is important. So I just provided the URLs of the file paths where this photos are belong to. And the second file contains the audio text. It writes down the song names and if you can retrieve the approximate date of the song, it might be anonymous or sing by a remix from another player, singer, it doesn't matter. You can type into the dates also, and you can just share the location, link, etc., etc. This file will be just studied in the future studies of this local intelligence project in a general scope. We are looking after a large database by which we can conduct further researches in terms of journal articles or conference publications with your contribution and with you as writers. So we would like to encourage you to contribute this data set while you're dealing with it in the workshop right now. So if you would like to contribute this database, you can just Mustafa, can you turn back to the drive folder?
Yeah.
Okay, you see the participant databases folder. You can just click and upload a new folder under your name and type in your find values labels into the same organization like that. Sorry, I just forgot it. So interested, Mustafa, you can continue. Thank you.
Okay. So I will just explain why we, as Selen explained, why we just extracted spectrogram images of the sound file. So we are using pix-to-pix algorithm, and it uses two images as input. So one is like an input file, and one is a target file, and it will just connect, just find the relations between the two images by pixel, processing them by pixel, and then after some training, it will learn what pixel is represents what on the target image, so that it can create after training, it can create from spectrogram files to it can create a new architectural image, or from architectural images, it can create a new spectrogram files that we can convert to audio files to listen or etc. This is why we are creating the spectrogram images of sounds, because in pix-to-pix, it's very easy algorithm. We choose it because it's very easy to use and it's very common, and it shows almost no errors in any programming or any running. So we choose pix-to-pix to work with, and it works with two images. So this is why we are creating spectrogram files. Again, I will just continue here. This is just another spectrogram file. These are all spatial to your sound files. It is just, again, it's like a fingerprint. It's not a signature, it's like a fingerprint of sound files. So there's no another spectrogram files like this to belongs to another sound file. You can just use this one if you just only to generate architectural images from spectrogram files. But if you just want to reverse the process, I suggest using again this mass spectrogram files to run with. Okay, so this is the data preparation part, as Selen explained it again, but I will just go over it. This will just resize the spectrogram images in your drive folders, and it will just save them to another destination path you defined here. It will just open, and resize this part. Like this is the pillow library. This is the feature of it. It will just open it and resize it easily. And then again save it to the folder you defined here. After that, this one is the resizing the architectural images. Again, the same algorithm actually. Yeah. It will just open the image and resize it and save it again to the destination folder you defined here. After that, for Pix2Pix to train the data, we just have to pair them. Like there should be one single file of containing two images. I will show you this one. Yeah. Okay. The data must be like this. This is this mass spectrogram file. This is the architectural image. This is your input file. This is the target file, and it will be the one single file to work with the Pix2Pix, or the another type, the amplitude spectrogram file for this. This is the input file. This is the target file again. So for creating this pairing, this pair of images, we just run this part of the code. It will just source 1 and source 2 files. One of them is architectural images, one of them spectrogram images, and it will open, pair them together here, the image 1 and image 2. It will just pair them here and save them to the your destination folder you defined here, and you will have these image pairs as single file like this. So after pairing the images, we'll just have to prepare the Pix2Pix algorithm. This NumPy and TensorFlow part is the machine learning part of the Python. TensorFlow is a very strong machine learning library, and we will just work with it. NumPy is a file reading library, and OS library is, as Selen explained, just for accessing the folders in your computer or in your drive. We will just run this to import the libraries. After that, we are loading images we just paired here. You can just define the size of the images. We are working 256 to 256 pixels images, and when we pair them, it becomes 256 to 512. But you can resize it like 512 to 1024. I will show what you have to do this. But let's stay with the initial one for now. Okay, so it will just read the path you defined here is the pairs, image pairs of the path, and it will read the images from here. It will just again split them for it to read, like okay, so it will split them. The first part of the first 0 to 256 pixel is the input and spectrogram image pixel part, and the rest of it is the architectural image part. It will just load them and zip them. This MPZ folder is like a zip folder, array zip folder for Python, and it will just read all the images and zip them together to work with more faster after that. So if you just run this, it will create this is actually file name and location. Actually, this part is the again location, and you can just change it to save your MPZ file wherever you want. After that, like here, if you just run this part to just confirm you just create the right image pairs. If you just run this, you will see that, yeah, okay, this is the input part, this is the target part, so this is correct. After that, we will just develop and train a pix-to-pix model, but we can continue to explain this part tomorrow, maybe. So we can give you some time to create your data set, maybe.
Yes, we are already ahead of time. And for today, you may want to just try to prepare your data set, as Mustafa told. And you may want to create your data set from scratch, from the way Selen introduced you to that, the techniques and the resources and the model. So you may want to create your own data set, or you may want to use the one that we directed you to. So please practice it during the rest of the day if you have time, so that you are more comfortable with all the environment and why we're doing what within the notebook. And with your questions, we can meet tomorrow at 10 again. And the recording, we're gonna upload it on YouTube, hopefully, and also at our Discord channel, as we told earlier. So do you have questions that are not clear? For total beginners, it's not easy to digest it directly. So you want to try to see what's going on these lines. If there are any questions so far, you can ask.
Just a question about the database Excel sheet. Is that done manually?
Excel data sheet.
Yes,
Yeah.
it's kind of manual thing, but by writing the file names using the Python code, it is easier that way. You can directly drive data in terms of the Excel sheet driving from the Octoparse network. It gives you the file names in terms of locations. You can just copy and paste that location, but it's a manual process. Not a code for that, unfortunately.
Okay, I'm gonna try to wrap my head around this. Let's see how
Okay.
much I can.
It's better for you to just collect the data set for the future purposes. It's not an urgent thing for the workshop, but if you just want to collaborate and not think in the bigger scope of local intelligence project, we would like to encourage you, but not a necessary thing that you have to deal with in the scope of the workshop.
Sure. All right, cool.
But if you're just planning to use it in your journal articles or your thesis, it might be necessary for you to document all this data where they belong to, etc., etc.
All right.
So okay, I just want to explain something too. You can have some permission errors if you just run this code this way. these folders is created by us, and we don't want them to be changed, so that we just restricted permission. So you can just open your own folders in your drive, and you can give them give their location here, so that you can work with them.
The same steps that we have just followed while transforming the images. So you just copy the path and paste it into the correct folder name.
Like you can just create, I don't know, not this one, state set. Okay. So I'll just create new folder and say new walls. So after that, you can just give them here, right? And it will give you not permission errors. It will work fine, but you have to create your own folders. That's new ones, and you can just create the right click on the mouse and click the copy the path. And when you came here, when you click paste, it will just click paste the path from right here. It will become easier, I think. But if you just if you try to work with our folders, our data ways, it will just give you some permission errors.
So is there any questions related to this stuff? Okay, that's fine.
Okay, then let's meet tomorrow at 10 a.m.
So if you have any questions while we close the session, you just feel free to write on the Discord, and we would like to help you if you can.
Okay.
There is a question.
I have a questions. Is that possible to make the music to 3D game? Is that possible? We can combine the music to 3D game.
3D game.
Yeah.
3-dimensional machine learning process is a little bit complicated, since the theory is just like based upon the image right now. And the current time being, we are not able to applicate it into like a space formation kind of like this works. Right now, all the provided GAN algorithms are based on the images, basically. That's why we will just use it as like a transformation from image from audio to image. But as I suppose in the future, there will be like a future work to implement it in a 3-dimensional organization as well. For this related work, not in the scope of workshop, but you might want to check the machine learning algorithms done with the space and text modules in terms of the spatial qualities, since it gives the syntactical measures in terms of mathematical equations that you can directly generate a 3D model of a GAN algorithm, but it's not actually like a 3D output, but you just measure the 3D space and write it down as like a mathematical code, and you generate the model from that code from. It's a kind of like a simpler process, text to image process, but it implements a little bit 3Dness of the space at all.
Okay.
So,
yeah.
And Yang Wang, I'm not so sure that I pronounced right, but we haven't yet like published any paper, but there are some couple of papers that in work in progress. So we will just like, I would like to like publish many more papers into that scheme. For both of us, we have individually published a couple of papers related to this GAN algorithm. You might want to check these, and we will be, Mustafa and I will be proceeding in the ASCAP in the upcoming October in terms of one another GAN algorithms named as the cycle GAN and style GAN, and the scope of urban map generating, something like that. But right now, and under the scope of local intelligence, I can't share you with you guys because we haven't published yet. Sorry.
In terms of the trusted knowledge and the latent space in architecture and AI in architecture, you may look up under my name. Again, let me write it down. On the theory, you may find some information. I have a few papers. So, any other questions before we leave?
Or comments of our pace, was it, were you able to track it with the pace, or was it slow, or was it fast?
I just want to add something too. When you are trying to create your data set, when you're trying to run the notebooks in Colab, if you get some errors, if you get some troubles, if you have any questions, you can just write them on the Discord and we will just look at them and we will return to you.
Okay. So bye for today.
Okay, goodbye.
Okay, thank you. Bye-bye.
Thank you.
Thank you.
Thanks. Goodbye.
Recording için buradan kapatmak. Mustafa